Thank you, Joe, for the quick introduction. My name is Jeremy Zuber. I'm the product marketing manager for the Overland Storage NAS product line, which includes both our Snap servers and what I'm going to be talking about today, the SnapScale NAS, which is our scale-out or clustered NAS solution. So I'm going to give you an overview of SnapScale, how it works, how we position it, and really how our end users use it to solve their top IT challenges. We're also going to look at the features and benefits and go into a little bit of detail on what SnapServer can do, how it does it. But we are going to do a deep dive after my presentation. My colleague here is going to give a much more specific and detailed view into our RAINcloud OS, which is the operating system that powers SnapScale. So if I can't answer a question, I will defer to Kevin over here, and we'll try to answer everything that you'd like to know. Okay. I do want to keep this interactive, so please just fire out questions as they come up. First of all, what I'd like to talk about are the top IT challenges. So in 2012, ESG did a survey of over 400 IT professionals and asked them a simple question. What are your biggest challenges in terms of your storage when it comes to your infrastructure? Well, number one is really the rapid growth and management of unstructured data. How do administrators handle unstructured data as it's growing exponentially? And also, how do they protect that data? How do they ensure that they have enough storage to protect that data now and to grow with that data 3 and 5 years down the road? And then finally, as Joe touched on, do administrators have enough physical space to capture all that data? Can they add more racks? Can they add more power and cooling? Do they have enough space within their existing racks to add enough storage? And how will the administrators of these enterprise IT environments address this massive data growth? Now, I also like to start off with a few Wikipedia definitions. Now, I know all you guys are very technical here, so one of you may have written these definitions since I got them from Wikipedia. But we'll talk about unstructured data, okay, which is data that's not associated with a database. Okay, flat files like PDFs, Excel docs, Word docs, anything that's not associated with something like an Exchange database or a SQL database. As we touched on before, the differences between traditional NAS or scale-up NAS and clustered NAS or scale-out NAS. The SnapServer products are traditional NAS, meaning they have a head unit with associated JBODs behind them. This does a few things. It's not only ubiquitous in an IT environment, but it introduces single points of failure into a lot of environments. It can still be protected with things like RAID, but when you're talking about network connections going through one head unit into multiple JBODs, you can run into issues as you start losing drives or connections between JBODs and the head unit. So scale-out clustered NAS addresses this by allowing you to add what are called nodes to your environment. All the nodes are equal. They all work together to provide a connection into and a service point allowing clients to access and save data. It's also a very high performance solution due to its architecture. Okay, and then the global namespace, which is really the gist of scale out. Why manage islands of storage on different vendor storage servers when you can manage one global namespace and provision that using our thin provisioning volumes on the SnapScale product. Now, you saw this slide before, the SnapScale family. The SnapScale X4 was introduced October 2012, so it's just about a year old now. That's our performance play. 2U 12 bay. You can start off with as few as 4 drives in a SnapScale X4, and you can scale up an existing cluster by simply adding hard drives to the empty slots in your units. We require a minimum of 3 X2 nodes in order to form a cluster. And we give customers the choice whether they want 1 gig or 10 gig networking. And I'll show you a bit on the topology later on how they're connected together. The X4, the larger, higher density scale-out NAS solution, can have as few as 12 drives per node or as many as 36 drives per node. So very high density, high performance, with the same types of network options, 10 gig or 1 gig for both the back end and client networks. Both units use nearline SAS drives, so either 2, 3, or 4 terabyte nearline SAS drives. You can also mix and match the units together in the same cluster as you grow a cluster out. Start off with X2, move to X4, and so on. And finally, both of them run the RAINcloud OS. We're at version 4 right now, but this is the real magic behind SnapScale, and allowing the SnapScale nodes to provide that global namespace.
Okay, since the drives are just connected to one controller, why NL SAS and not SATA?
We show better performance with NL SAS. We also want to differentiate between SnapScale and our Snap server line. So NL SAS is a way to do that.
Okay.
Good question.
So is this adding JBots or adding nodes when you're scaling in a rack?
When you're scaling with SnapScale, you start off with as few as 3 nodes, and you add more nodes as you go. So you add nodes in pairs, and they can be partially or fully populated when you add them.
And that's for both models?
Both models, yeah.
Okay.
They both run the same OS and operate in the same way.
Is the data redundant across the pair of nodes? Is that?
Yes, and we'll get into that. Absolutely.
And it's all spinning disk?
It is all spinning disk currently. Yes. Okay, so a little bit of detail about the SnapScale X4. Up to 1.4 petabytes of raw storage in a 42U rack. So this is our density play for backup, archiving, high performance storage. Start off with as little as 72 terabytes, which is 12 2 terabyte nearline SAS drives per node. And scale that up to massive amounts, okay, into petabytes of storage by adding additional nodes to grow that.
Cluster is a minimum of 3 nodes?
Pardon me?
Cluster is a minimum of 3 nodes?
Minimum of 3 nodes, yeah. 12 drives per node with the X4. 10 gig and 1 gig options. The X4 has 64 gigs of memory, so it's very beefy hardware-wise, but it has to be. You know, it's got 36 drives in each node. It's got to be able to keep up with all the data flow. And we've got all the block and file protocols. We've got SMB. We've got NFS v3. We've got FTP, HTTP, SNMP. And our block protocols, we have iSCSI. So it is a unified storage scale-out NAS.
What version SMP did you say, SMB 3?
We have SMB 2.1 compatibility. Okay, the X2, not as dense, but when I talk about density, I talk about the number of hard drives in a rack. So you can fit 10 of the SnapScale X4 units in a single rack, which is 50% more dense than the X2. But with the X2, you can fit 21 nodes in a rack. This is why this is the performance play. You can add a lot more processing power, a lot more memory, a lot more network connections when you're using the X2 system. Same networking options, 10 gig and 1 gig for the front end and back end network. And same protocols, since it supports the same version of RAINcloud OS, version 4. Now, this is the SnapScale typical topology. So what you'll see here is you'll see multiple SnapScale nodes. And you'll see a mix of the X4 nodes and the X2 nodes, which is perfectly acceptable. They're connected in 2 different ways. They're connected first via the back-end network. So this is where all the intranode communication occurs. This is where all the redundant files, all the metadata moves over, and all the intranode communication happens over that back-end network. So this can be a 1 gig or a 10 gig Ethernet network. Ideally, it's 10 gig. That will speed up the cluster, allowing the nodes to communicate faster. The nodes are then connected again to another network on the front end, or the client network. This is where all the clients access that global namespace. So you'll see all the clients tied into that namespace, and they interact with that global namespace through shares, which are presented on thinly provisioned volumes. So all these volumes can be created without limits by the administrator, meaning the volumes will simply take on the size of the available space in that global namespace at any given time, meaning there's no micromanagement of different departmental or server provision volumes in a SnapScale environment.
Is a volume locked to a node?
Is a volume locked on a node? So you mean, is a single volume associated with a single node? No, no. The volumes are spread out on multiple drives on multiple nodes.
Okay, when you say global namespace to me, then I'm thinking, that tells me that it's a system that's distributing data across the nodes on a file-by-file basis. Is this file distribution, or are you striping below that?
We are, I'll get into this in a little bit more detail in a few slides, but we're doing essentially file mirroring between drives, and we're also doing striping as well.
Okay, I'll let you go till you get to later before I start yelling at you. Go ahead.
So what this does is it also creates complete redundancy, right? You can lose network switches, you can lose nodes, you can lose drives, and still remain connected to that global namespace as a client. So what we say with SnapScale is don't worry, keep growing. And this is really where our scale up feature becomes important. So as a customer, as an administrator, you can start off with as few as 3 nodes and populate those nodes as you see fit, right? You can start off with 12 drives. Simply add drive 4 packs as you want to grow, and grow that global namespace on the fly while all the clients are connected and actively using their data in a SnapScale. What do you do after that? What if you want to add more performance? What if you want to add more storage? Well, you simply add more nodes. You can add nodes in pairs. They can be partially populated or fully populated. Once you add those nodes, you can add additional drives to those nodes until they're fully populated and continue to grow that global namespace. We have some administrative tools that make it very easy for the IT person to add nodes, to add drives, and then to make sure the cluster is balanced after that, because balance is something that becomes very important.
Are there 3 copies or 2 copies of the data?
We allow both. So we have 2 redundancy methods, one which we call 2-way and one which we call 3-way.
What's the difference? I'm kidding.
I was ready to answer that too. So with our architecture, and that was a great segue into my slide here.
That's what I'm here for.
3-way redundancy, so 3 copies of each file on the cluster at all times. This allows customers to really maximize that data protection, whereas the 2-way redundancy, not as much data protection, but more usable storage. Right? So maximize storage space, still with 2 copies of the data existing in the cluster at all times.
Is there RAID protection within a node or anything like that?
Not within a node. What we do is we have an architecture in which we use something called peer sets. So we create peer sets between drives on different nodes. And the peer sets stay in sync when data is written to them. That's how you can lose drives, that's how you can lose nodes, still be up and running and still be connected.
So if I'm doing 3-way redundancy, then the same data objects appear on a drive in 3 different nodes?
That's correct.
So if a drive fails, I need to rebuild all that data on a one-to-one basis to a new drive.
Yes, we have a technology that helps you address that. It's called rapid rebuild, and I'll show a slide on that as well. Great question.
Oh, if you like those, they'll get harder.
Yeah.
Ask Joe, he knows me.
Again, we do have a deep dive after this, so we'll get into all the juicy tech details. It'll be great. So in the event of a node failure, right, what we do is we do connection balancing for the different users connecting into a SnapScale cluster. So the users connect in through different nodes to make sure you're not overloading individual nodes at any given time. But what happens if a node fails and you're connected to the cluster through that node? Well, we use virtual IP addresses. So we simply reroute that user in through another node so they can regain connection to the cluster and all of their data. In the event of a drive failure, as I mentioned before.
Are you keeping TCP connection data across all the nodes, or am I going to have to hit a retry on the user workstation?
Kevin's got a lot of detail on that.
I told you they were going to get harder.
I expect them to. So that drive fails. What occurs? Well, I mentioned peer sets before. The remaining drive in that peer set that's had a failed drive is going to start rebuilding to a drive in another node. Okay, so ideally, you've got peer sets, of course, scattered throughout the cluster, but you've also got hot spares scattered throughout the cluster. Which means if you're rebuilding one of those peer sets, you're rebuilding to a drive on another node, and you're using rapid rebuild to move the files onto that drive to bring the cluster back up to high availability very quickly. Now, I touched on this a bit, but it was really important for us to create a unified storage architecture within RAINcloud OS and SnapScale. We want to give customers the ability to have that high density, high performance storage and serve up all the file protocols that they need for sharing, for backup, for home directories. Complete integration within Active Directory. Really make it easy for them to join that security environment which they currently have and which they need. And also iSCSI. So you run your virtual machines, you run your database files in SnapScale, and you host all of that data in the same global namespace. It is provisioned. You have your iSCSI LUNs, and you have your NAS shares, but they still can grow into that global namespace as long as space exists. When space runs low, you can add drives, you can add nodes, grow that namespace on the fly, grow the LUNs, grow the shares.
Your iSCSI LUNs, do they live on a node or are they distributed?
They are distributed. They are striped between different peer sets on different nodes. So just like the file data, all of the iSCSI LUN data is distributed and just as protected.
Is distributed on different nodes or all the nodes?
It's striped across multiple drives on multiple nodes. So
I'm waiting for the deep dive.
Yeah.
we have an algorithm which really tries to spread data out, is the idea. So you may have one LUN that occurs on individual, on a drive here, a drive here, a drive here. You may have data on another LUN that occurs on one of those drives there, another drive there, another drive there. So it is distributed throughout that cluster. Okay.
What happens if you lose a node for a few minutes?
If you lose a node for a few minutes?
Yeah, and it came back. So do you need to do some rebuilding stuff, or you have a log to check if something changes in the meantime? Because it's a huge amount of data.
Each node really keeps track of all the other nodes. So there's a database that resides on each node that knows a lot of information about the drives and the data that occur on the other nodes. Okay, so if you lose a node momentarily, the users are going to be redirected so that they remain connected, and the system may not be highly available, but the system will return to high availability when that node comes back online, and the data on the peer sets can be reestablished.
Is a node single controller or dual controller?
Each node is single controller.
And so on every upgrade of a node, you do have connection loss.
An upgrade of a node, you have connection loss. So what do you mean? You mean adding nodes to an existing cluster?
Firmware upgrade.
Firmware upgrades? Or don't you do firmware upgrades?
Yes, we...
It's perfect as it is.
That's a low blow.
Just swap a node.
You can update the RAINcloud OS. SnapScale will essentially upgrade itself, and we have a rolling update feature which we're working into the next version.
We can go into more detail in the next part of the presentation. You can ask us more questions on that if you want.
Okay.
We will.
So we have a couple tools that make it easy to keep SnapScale balanced, right? When you add drives, when you add nodes, you may run into situations where your users are hitting the first 3 nodes that you've added, and the new nodes that you've added have hard drives on them that are essentially empty. Or maybe they're hitting the new nodes, and all the data that's residing on the previous nodes really aren't being used. So what you want to do in a clustered NAS environment is you want to spread that data out again. You've just added more performance. You want to make sure you can use it. So with the data balancer, which is a user-initiated action, you can say, OK, I've just added new drives on new nodes. I want to balance that data so I can take advantage of all the processing power and all the spinning disks in each node.
So rebalance is a manual operation?
It's a manual operation.
Is it scriptable?
Is it scriptable? Can we script it? Yes.
Yeah.
Okay.
Yeah.
Can I limit when it runs? So I've got a large enough cluster, if I start a rebalance at 5 o'clock in the afternoon, I don't want that balance function running by 9 o'clock in the morning,
Yeah.
whether it's done or not.
Yeah, what you can do is it'll give you an estimated time that it will finish. You can stop it at any time, and you can resume, when the people leave that next day.
Okay.
Absolutely. It's a background process that can be done while the system is being used. So what about hot spares? Well, if you run into an issue where you've had a drive failure, and let's say you've got one hot spare per node, for example. One hot spare per node may be overkill in very large deployments, but if you start off with 3 or 5 nodes, you may have one of those 36 drives in each node acting as that hot spare. But if you do lose a drive, and you're using rapid rebuild to rebuild that drive to another node, you're going to run into a situation where you have a hot spare imbalance, meaning we've used up our spare in our top node, and we've got 2 hot spares now in our middle node. So we want to optimize data protection by using the spare balancer, the spare distributor, which is another user-initiated action, to go ahead and balance the spares by creating that spare back in the top node. So you've only got 1 spare per node now.
Why would it use a spare in the other node while there is one in the node where it failed?
Well, you have to, if you've got a peer set where you've got a drive here, you can't rebuild it to the same node. You've got to have peer sets that exist on drives in different nodes.
Yeah, but if there was a failure in that node, presumably there was a peer set at one time to that node, but it's got a spare in that node. Why wouldn't it just use that spare in that node to rebuild that node's peer set?
You guys are exactly right. It will use the one in that node. It's going to nominate a eligible spare and pick one. It could be from that node. It could be from another one. But you're right. It could have used that one from that node.
But it's not going to do it within the node preferentially?
No. No, there's no advantage necessarily to doing it in that node, actually.
You wouldn't think
It
that
avoids the need to have to rebalance later.
You're
No.
working in
No, the
virtually
data-
aligned
no.
groups?
the data's
data
coming
is
from
actually-
another node.
Yeah, the data is
Regardless,
on another
right?
node that you have to get it from to
So
rebuild.
you're working in virtually aligned disk groups?
Yes.
Okay,
Yeah.
that answers the question.
Okay.
Great questions, guys. Great questions. So let's talk about rapid rebuild. So when comparing SnapScale to a data protection scheme such as RAID 5 or RAID 6, SnapScale is not looking at the blocks, right? You're not doing a block-for-block mirror between the drives in the peer sets, which gives us an advantage when we have to rebuild a drive. Because in a traditional RAID array, you're doing a block-for-block rebuild. You're going to move over all the blocks of data from the parity, reconstruction of all that data. You're also going to move over the blocks that occur in the free space on that data.
Well, if I'm an especially stupid RAID controller, yeah.
Sure.
Not to say that major vendors don't make especially stupid RAID controllers, but
Sure. In some boxes, this will occur.
you're talking about nothing anybody in this room would consider modern that came out in the last 5 years.
Yeah, a scenario where you've got that traditional RAID. There are technologies around that, but SnapScale, the architecture, is different. I guess my point is not a block-for-block reconstruction, right? You're rebuilding a drive, you're simply moving files over from the remaining member of that peer set to a new spare drive. Meaning if this drive is only partially full, it's going to rebuild much faster than a parity rebuild in a traditional RAID array.
Okay, so that's clear if I'm storing files. But if the data on that drive was at least partially an iSCSI LUN, then
Which might be a file on top of the file system.
right. So if the way this is sounding right now, a file lives on a drive and its replicas, and therefore, and if the iSCSI LUN is a file in that file system, then the performance of an iSCSI LUN is limited to the 100 so IOPS that one NL-SAS drive can deliver, and that doth sucketh. So I am assuming that that's not what's going on.
Not what's going on.
But if that's not what's going on, then we don't understand how this recovery works.
Well, you can consider the file as being striped across multiple peer sets. And so the file doesn't reside just singly on a single drive and a single peer set, but rather it's spread out across multiple peer sets.
Okay, so you're not saying that in the event of a rebuild, you're going to copy the files from a replica to the hot spare. You're going to copy file shards.
There you go. Yes.
Okay, so files are sharded across
Yes.
N drives.
That's right.
Okay. More questions in the deep dive.
Yes.
Are you writing them down?
Oh, I don't have to write them down.
Good, I'm sparking your interest.
All right.
So yeah, as you can see, the faster you can rebuild a drive, the faster you bring the cluster back up as a whole to high availability.
Right, which frankly makes the whole idea of peer groups stupid. Because if instead of having all of the shards on drive 27, regardless of what node it's in, duplicated to drive 86 and 142.
Howard, can you let him go so that we can get to that second part of the presentation?
Sure.
This was actually
I'm
kind
not
of
sure.
interesting, but okay.
No, don't worry, we'll come back to it.
Okay.
I won't let stupid stand without explaining. That would be rude. As if stupid wasn't rude to begin with. Go ahead.
Yeah.
Trust me, you don't want me to babble on. Start talking.
So what's another way we can protect data? Well, data replication, right? We have a replication tool called Enterprise Data Replicator that allows you to replicate on a file basis, on a scheduled basis, between SnapScale clusters and also our Snap Server NAS. And we also allow customers to build their own cloud replication as well, using Unix, Linux, or Windows servers. So all these different types of servers can play in sending or receiving data to each other over the internet.
And it's asynchronous. It's file level.
File level.
Snapshot kind of thing. Scheduled.
Yep, schedule-based, byte-level incrementals, compression, encryption. So it's very efficient, especially if you have small file changes, even among large data sets. So one thing that's very unique is that we allow multiple products in our product line to participate.
And the product supports snapshots.
We can replicate snapshots from our SnapScale systems and our Snap Server systems. So yes. So we have customers that use our what's called the latest directory that occurs on our file system, which is always the latest snapshot. So you set the servers to replicate latest over to the remote site, and you're always replicating the latest snapshot in that directory.
And do you have a way to manage snapshot at the user level, so the user sees something like a snapshot directory, and you can go into it and get all the versions of the files?
Of course. So that the snapshot share is able to be presented to any user on that network, so they can go and recover files individually. Absolutely.
And we create snapshots are at the volume level?
Yes. Yes.
Okay. And while it doesn't sound like conceptually it's something you really say, snapshot volumes are thin provisioned?
Snapshot volumes are thin provisioned.
Well, I mean, you've got a global file, you got a global namespace, and we're introducing the concept of a volume into that. Are those volumes of fixed size, or are they thin provisioned?
They're thin provision.
Okay.
So really, we position SnapScale for those customers with massive amounts of exponentially growing unstructured data, right? Allowing them to eliminate bottlenecks on their network by preventing islands of storage, preventing single points of failure, allowing users to maintain access in the event of a node or drive failure.
Are there limits to the number of nodes that can be in a cluster?
The limit is with the number of peer sets. So we have the ability to have up to 64,000 peer sets of drives. That's the theoretical limit of SnapScale. Okay. We think users are going to be, in the realm of
So 32,000 nodes, is that the kind of number we're talking about?
Well, remember, there's either 12 or 36 drives per node, so you
So
basically.
they're 12, divide that by 12 or 36, yeah.
Yeah.
You say basically half an exabyte, right? On one of
512
the previous slides.
petabytes.
Yeah, which is a theoretical limit.
That's
that
a
RAINcloud
global
allows.
namespace theoretical limit, yeah.
All right.
Yeah, but,
the real
you can
question.
ta-
The real
the-
question is, how big have you tested?
How big have we tested? Yeah, 50 nodes,
50 nodes?
50 X4 nodes.
50 X2 nodes.
Okay.
X4 just released last month, so we're still working on testing for that. But
Okay.
I've got a test report we did with Tolly, which was very positive.
And a peer set is a drive to drive
Yes.
pair?
Yeah, a pair or a triplet.
Triplet.
Yeah.
Good. Okay, so our latest version of RAINcloud OS, version 4, just to give you an idea of what we include in our operating system releases, we added the iSCSI feature, we added the striping feature for higher performance, the data balancer, the spare distributor, and then the alert system that's associated with those and their user-initiated actions. So the next version is in development. We have a lot of exciting things that we're working on with SnapScale.
What do you think the advantage of the peer set configuration versus standard, RAID or mirroring kinds of things? It's the first time I've ever heard peer set kinds of solution in this space. What's the advantage from your perspective?
One advantage is when you're adding storage, right? When you're adding to a RAID array, you got to restripe that data. When you're adding to a SnapScale cluster, you're simply adding drives that form new pairs, right? So those drives are added to that global namespace almost instantly.
Yeah, but all the drives in the current configuration are all paired at this point in time, right? And you're adding a new set of pair of nodes, right, I guess, so that's why you have to add them in pairs.
Right.
If you had a triple-way configuration, you'd have to add them in three units? Is that the way it would work?
And remember, you can also add drives to partially populated nodes, right? So
As long as you add them in pairs or triples, is that?
exactly, on different nodes.
On different nodes.
That's exactly right.
So the nodes have to be homogeneous. They have to be the same size. But you mentioned you could be X2 and X4 configurations.
They can be. They can
As
be.
long as
but
they're pairable, right? So they're two pair of X4s or triplets of those.
you can actually mirror data across the different systems, but you need to make sure you've got enough drives, right? So if you've got X2s in an existing cluster, and you're adding X4s, you're only going to be able to support 12 drives from an X2 into an X4, right? So you have to make sure that you're adding the
Those
drives.
other drives are effectively useless because they can't be paired to anything.
Well,
Real quick, I'm going to just help out a little bit. You guys are getting stuck on the node idea and concept. It really has nothing to do with how the peer sets are created. We're talking about adding nodes, adding 2, adding 4, adding 3. It doesn't really matter. You can start with a 4-node cluster. It's fine. With 3-way replication or 2-way replication, what happens, the algorithms, and Kevin's going to go into this. You guys are like way ahead because you're so smart.
Well, yeah, way ahead.
But
I mean, the data
Kevin's gonna
landing
go
is
into
actually
this.
pretty important to know what's happening with all this.
That's right.
On
So-
top of it, so we're not getting the data landing yet.
Yeah, we're trying to get there, but I want to just kind of help with this part because we're getting stuck on a concept that is not real. What Jeremy's talking about is a method that we describe to customers so they don't get themselves into a situation where the transfer of data is more complicated or difficult. So if you can imagine, you start with a 3-node cluster.
no problem. You can add a single node, fill it up with drives, no problem. Remember that rebalancing feature? Rebalance. It'll go through, it'll figure it out, and it'll take some time, and it'll rebalance. And it'll reassign the peer sets, and it'll do that.
Okay.
It takes a lot longer,
Yeah.
right? It's a little more complicated.
Really, the scale-out unit is the drive.
That's right. The unit of measurement is the drive, not the node. So I
Which
just wanted to kind of stop.
Which means that, at least to some extent, drives have to be similar sized.
Yes. For optimal configuration, absolutely.
Yeah.
Absolutely. So anyway, so I didn't want you to get stuck on the fact that you felt like you had to have nodes matched up in pairs or triplets depending on what
let's say you have a configuration of 3 of your X2s, which are all 12 drive populated, and I want to put in another X2. I mean, how does this thing restructure the triplet characteristics so you actually use the new drives? I mean, I guess I don't understand how it plays out. Maybe we'll talk about it.
We will. In fact,
Yeah,
he's got some good slides that'll kind of go
Okay.
through, and you'll see how the data gets redistributed.
I mean?
as well.
We may even convince them to use the whiteboard, but
Okay.
Wait, we have pens.
We're ready.
We're ready.
I am holding.
All right.
Aw.
Yes.
Yeah, I just didn't want you to
I'm
get
trying
stuck
very
on
hard
that
to be
concept
patient.
because it's
Okay.
not really
All right,
related.
all right. Because I guess I
Not
was
good at that.
mistaken.
Yeah.
Sorry.
Cool.
I was
That's good. That's good. Good questions, guys. Thanks.
So really what we want to do with SnapScale is we want to capture this transition that we're seeing, right? ESG is estimating that most storage by 2015 will be of some type of scale-out technology, right? Whether you're doing replication, whether you're doing RAID, but you're spreading it out between different servers, different nodes, whether they're local or remote. So SnapScale will allow our customers to do that today, right? Where you've got multiple nodes and you're protecting data and you're always optimizing performance into or out of those nodes.